Have you ever seen one of those giant cruise ships or a cargo ship piled high with containers? How are these huge ships able to float on water? All these ships are made of steel, which is much heavier than water. So why aren't these ships sinking to the bottom of the ocean just like how a normal piece of iron or rock would? The reason is Archimedes' principle. Before we talk about the Archimedes principle, do make sure to subscribe to our YouTube channel and press the bell icon to never miss any video. Coming back to the video, we can thank the Greek scientist Archimedes for being the first to explain why objects float on water. The principle he formulated is known as Archimedes' principle. When a body is immersed in fluid, it faces an upward thrust or resistance called buoyancy or buoyant force, and the object displaces some amount of fluid. The magnitude of the upward buoyant force exerted on an immersed object is equal to the weight of the fluid displaced by the object. So this means that when a body is immersed in a fluid, there are two forces acting upon it. The force of gravity acting downwards by the object, which is determined by the object's mass, and the force of buoyancy, which is acting upwards on the body by the fluid. In simple words, if the force of gravity is less than the buoyant force, the object will float, and if the force of gravity is more than the buoyant force, the object will sink. Let us understand the proof of buoyancy with this small example. If you throw a stone from a height on the ground, the stone will land on the ground at very high speeds due to the pull of gravity. But if we put the same stone in a tank full of water filled to the same height, the stone will take more time to come to the bottom of the tank. This resistance which the stone is experiencing is called buoyancy or buoyant force. How can this principle be applied to ships? Ships are enormous steel vessels having a mass of hundreds of thousands of tons. Steel is much denser than water, so you would think that massive steel ships would sink, right? Well, think again. What helps keep ships afloat is their shape and what is inside them. Ships are not solid pieces of steel, instead they are mostly hollowed out from inside. There are all sorts of components inside a ship. For example, the ship's engine, fuel and cargo may be inside. But most importantly, there is air inside the ship. This air is called reserve buoyancy. The air that is inside a ship is much less dense than that of water. That's what keeps it floating. The density of steel may be much greater than water, but the average density of the total volume of the ship and everything inside of it, including the air, must be less than that of water. Only then the ship will float. If the density of the ship is ever greater than the density of water, then the ship will sink beneath the surface of the water. When a ship sinks, it is because of the water that enters inside the ship. This forces out the air, making the average density of the ship greater than that of the water. One of the most famous disasters is the sinking of the RMS Titanic. The ship struck an iceberg off the south coast of Newfoundland in the April of 1912. The iceberg tore open several small holes in the hull of the ship, letting water into the bow of the ship. As more water entered the ship, the air was forced out. This caused the ship to sink to the bottom of the ocean. Just like every other ship that ever sank, the Titanic ultimately went to the bottom of the ocean because of buoyancy, or rather a lack of it. Let us know in the comments what other maritime topics you would like us to make